Okay, continuing from question 5. It asks us to find f-3 of the graph alongside. So we know that f-3 means that we are finding the gradient of the tangent at the point x equals 3. So they've drawn that on here, and we have the tangent here that goes through the point here and here. So our points of our tangent are 0, 4 and 8, 0. So we'll call that point 2 and that point 1. So the gradient of that line is 0 minus 4 divided by 8 minus 0, which gives us minus 4 over 8, or negative a half. And we can see that that's sloping downwards, so we expected it to be a negative gradient. Okay, the next question, from first principles, find the derivative. Now we know that first principles means using our limit as h approaches 0 of the function of x plus h minus the function of x divided by h. So this is obviously another good one that we need to have in our reference page, and we'll have a look at that in a minute. So what we need to do first is establish what is the function of x plus h. So we'll have x plus h all squared plus 2 times x plus h. Expanding that out, we have x squared plus 2xh plus h squared plus 2x plus 2h. Putting this into our first principles formula, the derivative is the limit as h approaches 0 of x squared plus 2xh plus h squared plus 2x plus 2h minus our original function up here. We'll put brackets around it so we don't get confused about our negatives, and all of that divided by h. Now we need to simplify that top line, so we can see that the x squared has a subtract x squared, and we have a plus 2x here and a subtract plus 2x there. So we are left with limit as h approaches 0 of 2xh plus h squared plus 2h all over h. And we can see that we can take h out as a common factor. So we put h outside of 2x plus h plus 2 divide by h. So we cancel that out, and now we can determine the limit by setting h equal to 0, which will give us 2x plus 0 plus 2. So our first principles will give us 2x plus 2. Okay, the derivative of y. Now remembering that the derivative of y is dy dx. Done exactly the same way, just the different terminology. So it's still the function at x plus h minus the function at x over h. So we still have to know the function at x plus h, which will be equal to 4 minus 3 multiplied by x plus h squared which equals 4 minus 3 x squared plus 2xh plus h squared, which is 4 minus 3x squared minus 6xh minus 3h squared. Putting this back into our first principles formula, therefore we need to find the limit as h approaches 0 of 4 minus 3x squared minus 6xh minus 3h squared minus our original expression 4 minus 3x squared, all divided by h. Simplifying, the 4's cancel out, the minus 3x squared cancels out because we have the minus here, so it's minus 3x squared plus 3x squared, so that is equal to the limit as h approaches 0 of, making sure we take note of the signs, minus 6xh minus 3h squared over h, and again taking h out as the common factor, we cancel out the h's and now set h to 0, so the minus 3h disappears and we're left with minus 6x. Okay, using the same process, we're going to find dy dx equals f of x plus h minus f of x over h. The function at x plus h is equal to 2 x plus h squared minus 1, which is 2 outside of x squared plus 2xh plus h squared minus 1, or 2x squared plus 4xh plus 2h squared minus 1. Putting that into our formula, we have the limit h approaches 0, 2x squared plus 4xh plus 2h squared minus 1, subtract 2x squared minus 1, all over, oops, wobbly line, h. So that's equal to the limit as h approaches 0. The 2x squared minus 2x squared cancels out, minus 1 minus minus 1 cancels out, 4xh plus 2h squared over h, taking h out as a common factor, so they cancel out. Now setting h to 0, 4x remains, the 2h goes to 0, so our solution is 4x. So hence state the gradient of the tangent to y equals 2x squared minus 1 at x equals 4. So at x equals 4, dy dx equals 4 times 4, which is 16. And for what value of x is the gradient of the tangent to y equals 2x squared minus 1 equal to minus 12? So we have dy dx is equal to 4x equal to minus 12, dividing both sides by 4, we get at x equals minus 3. So it's just rearranging the equation to find both solutions. What is the x value and what is the y value? Okay. Here we have our graph of fx equals x squared minus 3x, x cubed, sorry, minus 3x squared. And it says find f dashed x. And then hence show that the illustrated tangents are parallel. So this is the one now that we can use our pattern, because it doesn't say we need to use first principles. So we can find f dashed x using the pattern. So remember, our pattern is ax to the power of n, f dashed x equals an to the power of x, n take 1. So f dashed x is going to be equal to 3x, 3 take 1 is 2. Now subtract 3 times 2, which is 6x. 2 take 1 is x to the power of 1, so we'll be left there. So we've found f dashed x. Now show that the illustrated tangents are parallel. Lines that are parallel have the same gradient. So we need to find f dashed minus 1. Is that equal to f dashed at 3? Is that true? So f dashed minus 1 is 3 times minus 1 squared minus 6 times minus 1. Minus 1 squared is 1, so it's 3. Minus 6 times minus 1 plus 6 is equal to 9. F dashed 3 equals, oops, sorry, that should be 3 cubed. Let's try that again. Oh no, it's not. Ignore me. So f dash 3 equals 3, get the pen back, 3 times 3 squared minus 6 times 3. So 3 squared is 9, 3 times 9 is 27, minus 6 times 3, which is 18. 27 minus 18 is 9. So yes, tangents are parallel. And that's the end of review set 14A.